Hey, what's up? Welcome to the Pre-algebra 8.2 video where we are talking about linear equations in two variables. Alright, linear equations in two variables. What in the world does that even mean? Okay, well, let's break it down. We have linear first. Well, linear means line, okay? And these linear equations in two variables, well, they are going to be graphable equations. So we are going to take equations, find their slope and y-intercept, or different points that they run through, and we're going to graph them on a coordinate plane like that. And this would be an example of a linear equation that is graphed. All right, so we're taking actual equations and turning them into lines. Something else to know is that there are two different variables, okay? Two variables. And we most often see them as x and y. All right, now we've dealt with equations in one variable, such as 4x plus 8 equals 10, right? And we solve for x. Well, now we have two variables, and so I'll get to examples of that in a second. Also, with linear equations in two variables, the solution is not a single number, but it's actually an ordered pair, such as the point -2, 4 or 3, 8. We're not just solving this, and subtracting 8 and subtracting 8 and getting 4x equals 2 divided by 4 divided by 4. And we would say, well, x equals 2 divided by 4, which is a half. That is not what we're going to get in this case. This would be, a single variable equation. But now that we have two variables, we're going to have points as our solutions. All right, so what are some examples of linear equations in two variables? Well, 2x minus 4y equals 10 would be one. So you have both an x and a y. Y equals negative 1/4 x minus 7 would be another example, okay? So any kind of thing where you have both an x and a y. Now, I said that the solutions of these equations, and keep in mind they are equations because they have equal signs, right? The solutions are going to be points. So what do I mean when I say that, and how would we find those solutions? Well, that's where we're going next. All right, so the first kind of thing we're going to tackle is determining if a given point is a solution of an equation. So what we're going to do now is figure out, is the ordered pair, or the point, okay, a solution of the equation. So here's the equation we're working with. And what we're going to do is we're going to figure out, are these 2 points solutions? So really what we're asking ourselves though here is, when I plug in the coordinates into here, or those into there, do I get a true statement? Okay, so let's figure that out. We'll do this first one together. So I'm going to rewrite my equation of 2x minus y equals 5. And again, I'm trying to figure out, is this point a solution? So what I'm going to do is, since I know that points are made up of x and y coordinates, I'm going to take my x coordinate of 1 and put him there, and my y coordinate of -3 and put him there. Now this is very, very important when you plug in, because you can't take anything away from the original. So 2x means 2 times x. So I'm going to write 2 and then parentheses for multiplication, 2 times 1. Now, here's why I say this is really important. Minus and then y. Well, no longer are we plugging in y, we're putting in -3. So it's minus a -3. Now you could write this with another set of parentheses if you want, and equals 5. Some people do the shortcut and just write minus -3 like that. And either way you do it, you know what's going to happen is that the double negative you have right here is going to become a positive. So let's simplify down. 2 times 1 is 2. Minus -3 just means plus 3, and that equals 5. So again, we're testing the truthfulness. 2 plus 3, if I'm simplifying that side, I get 5. And on the other side, we have a 5. So the question is, does 5 equal 5? Yes. Okay, so what's our answer? Our answer is yes. The point 1, -3 is a solution of this equation. Now, what does that mean? Well, in a kind of broad overarching thing, if we were to graph this equation, which we're going there, we're not there quite yet, but if we were to graph this, okay, it would look something, on a coordinate plane like that. All right? Actually, it looked probably a little different because, let's just draw another one. Okay, boom. Looks something like that. Okay, and what that means is that 1, -3 is going to be somewhere on this line, and specifically it'd be somewhere probably 1, 2, 3. So it'd be somewhere like that, right? The point 1, -3 would actually be on this line. However, what we're also seeing is that there are many points that are going to be on this line. So equations in two variables have not just one solution, although this is a solution here that we found. they're going to have an infinite number of solutions in most cases. So why don't you pause the video, and I want you to test this point. See if this point is a solution of that linear equation. All right, so I'm going to rewrite my original. And again, plug in our x and y coordinates. 4 goes in for x, 7 goes in for y. And so now we have 2 times 4 minus 7 equals 5. Or really, I should write question mark. Does that equal 5? Well, 2 times 4, okay, again, we got multiplication here, subtraction there. I need to do the multiplication first. So that's 8 minus 7. Does that equal 5? Well, 8 minus 7 is 1. And 1 does not equal 5, right? So what we would say is that the point 47 is not a solution. And if we go to our little kind of just quick sketch graph, we would see that the point 47, 1, 2, 3, 4, up 1, 2, 3, 4, 5, 6, 7, it's like somewhere up here. And this line is not running through 4, 7, okay? So there you have it. All right, so just to make sure we're really solid, I want you to pause the video and try this one, same kind of problem. All right, so is -8, -4 a solution of that equation, which is y equals 1/2 x? Again, two different variables in here, x and y, linear equation, right? So let's plug in. So -8 is going to go in for x, and then the -4 is going to go in for y. So if I rewrite, I'm looking at -4 equals 1/2 times no longer x, but now times -8. So simplifying the right side, what's a half of -8? Well, it's going to be -4. And so there's our answer. Since we get a true statement, we would say yes, -8, -4 is a solution of y equals 1/2 x. All right, so the next thing we're going to get onto is finding multiple solutions or points of a linear equation. In this case, we're going to focus on this equation, y equals 2x minus 1. So what we're going to do, again, because we know that a graphed linear equation is going to run through multiple points, and since it's got arrows on it, we know it's actually going to continue on this way into infinity and this way as well. We know that there's going to be multiple solutions, okay? And the other cool thing we know is that with an equation like this, there is going to be some point that's going to have an x-coordinate of -2, right? So if I went left -2, I would then go down to figure out, hey, you know what? There's some point that has an x-coordinate of -2. Similarly, there's going to be some point that has an x-coordinate of -1 and 0, and then some x-coordinate of 1, and then there's another point with an x-coordinate of 2, 3, 4, 5, right? There's another point that's going to have an x-coordinate of 5, and he's going to have some y-coordinate. All those points are going to have some matching y-coordinate, but we don't know what it is off the top of our head. So what we do is we make an xy table. And when we make an xy table, we put in standard values of -2, -1, 0, 1, and 2. And so what we're doing is we're basically finding points. And we're plugging in half of the point, and we need to find the y-coordinates to go with each of these x's. So how do we do that? Well, we're going to plug in -2 first in there. So now we have y equals 2 times -2 minus 1. And 2 times -2, that's going to get you -4 minus 1. And what is -4 minus 1? -5. So when x is -2, what is y? Well, it's -5. Okay, so why don't you fill in the rest of the table and then play the video when you're done, and we'll keep on moving. All right, so what is y when x is -1? Well, again, I'm going to rewrite my original, and I'm going to plug in, because this -1's in the x column, I'm going to plug a -1 in for x. And so now you get y equals 2 times -1 minus 1. Well, that's like saying y equals -2 minus 1. And what is -2 minus 1? You get -3, so I put it in a -3 up there, okay? And hopefully you got the rest of these values in your table. If you put in a 0, it'd be 0, you get -1, a 1, and then a 3. And so what we've done is we've actually found multiple solutions of that equation. And the really cool thing is now we can actually graph those points. So let's go ahead and do that. All right, so we've got a graph. Now let's graph the first point, -2, -5. So that means I need to start at the origin, go left 2, and then down 5. And then -1, -3, 0, -1, 1, 1, and then over 2 up 3. And there we go. And what we see is that we have all these points on a line. So what we can do is actually just take a line and strike it right through. See if I got it. It's not bad, but it's not perfect. There we go. A little adjustment. And there you go. We've actually just graphed that linear equation by making a table. And so just one more little extension here. Now that you've graphed this equation, list another solution or point. So take a second to think about that. Well, obviously I only have a limited graph here, but what I can see is that this line also runs definitely through that point right there. What's that point? Well, that's the point over 3 up 5, so that's the point 3, 5, okay? You could also probably kind of tell that the line's eventually going to go up there, and that's going to be 4, 6. Now you could also go in between the blue lines and say, well, hey, how about this point right here? Negative 2.5, and then down there to negative 6, right? So negative 2.5, comma 6. That again would be right there. All right, so I want you to pause the video and just kind of practice these, graph both of these equations, again using the table like we did just previously, and play the video when you're done. All right, so I remember if I'm going to graph these, I need to make that XY table. And I'm going to plug in those standard negative 2, negative 1, 0, 1, and 2. And so if I plug in negative 2 for x, I get y to equal what? Well, negative 4. If I plug in a negative 1 for x, it's like saying 2 times negative 1, which is negative 2. It's negative 4. If I put in a 0, I get a 0. If I put in a 1, 2 times 1 is 2, and then put in a 2, 2 times 2 is 4. So if I graph that, all I got to do is go left 2 down 4, left 1 down 2, add 0, 0, over 1, right 1 up 2, and then right 2 up 4, and there you have it. And you can just go ahead and make a line. Obviously, you're probably using a straight edge there. You can't do that here. Actually, you know what? That's no excuse. How about I do this? I will go back and I will actually use the little line tool. I just can never get it perfect. That's annoying. That's not bad though. All right, how about that? Okay, and then this one down here. Y equals negative x plus 3. Again, got to make that xy table. And I put in negative 2, negative 1, 0, 1, and 2. And so if I put in a negative 2 here, I got to be very careful. So I'll write this one out. Y equals negative x. So keep in mind, what does negative x mean? Well, it means negative 1 times x. And then we have this plus 3. So if I'm going to plug in a negative 2 and then a negative 1, a 0, 1, 2, I'm going to put it where the x goes. So it's like saying y equals negative 1 times, not x, but negative 2. Okay? And then plus 3. Well, what is negative 1 times negative 2? Well, that's positive 2 plus a 3, and 2 plus 3 is 5. Do the same thing, one more example. Y equals, again, it's negative 1 times x plus that 3. So now I'm going to plug in a negative 1 from the table. Negative 1 times negative 1 plus a 3. And then negative 1 times negative 1 is just positive 1 plus 3. And what is 1 plus 3? You get 4. So what would you do, or what would you get for the rest? Here it is. And then, of course, we would just graph these values. And I would start, oh, whoa, what happened there? Something crazy happened. Okay, we're just going to go with that. All right, negative 2, 5, so left 2 up 5. Left 1 up 4. There, there, and there. And those are your points. Again, connect them with a straight line. Oh, so close. Give them arrows. And there you go. You've graphed multiple linear equations now. Congratulations. All right, so the last thing we're going to talk about in this video is slope-intercept form. And it's the last thing, but it's super, super important. Okay, so slope-intercept form is also called function form. And it looks like this. Y equals mx plus b. Okay, so what do those things mean? Well, again, we're solving linear equations, and they are going to have variables of y and x. So y and x are going to stay the same. But m and b are going to be different numbers. So m is going to be the slope. Now the slope is technically the rise of a line divided by the run. Now what do I mean by that? Well, let's look at our line here, okay? So this line is obviously increasing from left to right, and I've labeled multiple points that it goes through. So let's start at this point here, and let's go to this point. And let's figure out, okay, how many do I have to rise and then run to go from here to here? Well, if I rise 2 and then run 3, I'm going to get to my next point. If I do the same thing, rise 2 and then run 1, 2, 3, I'm going to get there. So our slope in this case is 2 over 3. Now you might be saying, well, what if you go this way? Well, to go from here to here, I would have to go down 2, which is negative 2, over 1, 2, 3. And I'm going left 3, and so that's also negative. But what's a negative divided by a negative? It's always a positive, so the slope is the same no matter if you go this way or this way. So let's talk about the y-intercept. What is the y-intercept? Well, it's where the line, when it's graphed, intercepts the y-axis. So where's our y-axis? Well, it's the vertical axis. And where's our line intercepting the y-axis? Right there at 1 on the y-axis. And look what our, and so it would be 1. So if we were to formulate the equation in slope-intercept form for this line that's graphed, again, it's going to be y equals our slope times x plus, or it could be minus, your y-intercept. So what's our slope? Well, we calculated it. It's 2 over 3. And then what's our y-intercept? It's 1. So our equation is y equals 2/3 x plus 1. Now, this is super, super important, but the most important part of this for this video is looking at the form and putting it in that form. So actually, if you look back here, what form do you think this was in? Well, this was slope-intercept form. Our slope was this -1, and our y-intercept was 3, okay? What about up here? Well, the slope was 2. Did we have a y-intercept? Well, not technically, but it was, I guess technically speaking, it was 0. So you've actually already done this, but what if I were to give you this? And I said, I want you to put that in slope-intercept form. What would you do? Pause the video, try it, play when you're done. So what I hope you do is you'd subtract 2x from both sides, because again, you want it to look like y equals mx plus b. And so basically, in a nutshell, what that means is you want the y by himself on the left side, all alone, equal to everything else, the x term coming first, and then any constant terms, if there are constant terms, coming after that. So if you subtract 2x from 2x, they cancel and you get y. And that equals, and I could do 8 minus 2x, or I could do negative 2x plus 8. If you look at slope-intercept form, though, the x term comes first. So it's negative 2x plus an 8. Now, why didn't I make this 6x? Well, this is an 8 and this is a negative 2x. Can't combine them with subtraction. So I just write them both. All right, so last two and we'll be done. Put these into slope-intercept form. Pause the video, try that. Play it when you're done. All right, so again, slope-intercept form looks like y equals mx plus b. I want the y totally by itself, and then everything else on the other side. Now, sometimes b will be a number, sometimes it won't, and that's okay. So what about here? Well, the only reason y is not by himself is because there's a negative x. So how do you get rid of a negative x? Well, if I add x to negative x, they cancel. They become 0. But I have to do the same thing to the other side. So I'm left with a positive y, which is good. If it was a negative y, it wouldn't be done, equals, what's 0 plus x? Well, it's just x, and you're done. And then this one over here, well, so the y is not by himself, 1, because he's being multiplied by a 4, and the other thing is that there's a positive 8x on the same side. So what I like to do is get rid of the x terms first, right? And you can subtract the 8x from an 8x, right? You can get rid of the whole thing using subtraction, because 8x minus 8x is 0, or they cancel. If you divided 8x by 8x, well, that would be the number 1, and you don't want to do that. So we're left with 4y equals, again, this is a negative 12, this is an 8 minus an 8x, can't combine them. This is a term with variables, he doesn't have any. So I'm just going to write negative 8x minus 12. The last thing I need to do is, because y is still not by himself, he's being multiplied by 4, got to divide everything by 4. And when I divide 4 by 4, you get y equals negative 8x divided by 4 is negative 2x minus a 3, and you're done. And speaking of being done, you're done with this video. Thanks for sticking with it, guys. Sorry it was kind of long, but it's really, really important, and I will see you soon.